So as we're working on these, please do feel free to just unmute and let me know the answer here. Good morning, Lucy. Glad you're here with us. We're getting ready for a team quiz, Lucy, so we're going to go over a few practice problems here before we do that. All right, so what form are both of these equations in? They're both in the same form. What is that form? Yeah, and what's the name of that form? That's all right. Maybe someone else knows. What's the M stand for? Yeah, Naomi, you got it. It's the slope intercept form of linear equations. Slope intercept form of linear equations. All right. So we have these two equations in slope intercept form. In the chat, what method would you use to solve this system? In the chat. Yeah, Jojo. So yeah, you would. I wouldn't personally use the elimination method here, Jojo, but you can. Yep. I see what you're saying. So your idea is to multiply this equation by 2 and then add them together. That will work. But the method that I would use here, I would use substitution. Whenever we have one equation, at least one equation, when one of the equations is solved for one of the variables, it doesn't matter which equation and it doesn't matter which variable. In this case, both equations, both of them, are solved for the y variable. The y variable is isolated. So when that happens, you can take the thing that the equation equals and substitute it into the other equation. So we are going to we're going to do that now. All right, so we're going to use the substitution method. Because y is equal to 2x minus 1, we're going to substitute 2x minus 1 into y in the other equation. We could have done it the other way around and substituted the negative 4x minus 7 into the first equation. That would have been just fine. Ultimately, it turns out to be the same thing. So we have 2x minus 1 is equal to negative 4x minus 7. Please do stop me if you have a question. Good morning, Tran. Glad you're here with us. I'm going to get all of my x terms on one side by adding 4x to both sides. So that makes a 0 over here. On the left-hand side, we have 6x minus 1. Then we have our equals negative 7. This makes a 0, so it's 0 minus 7, so that negative 7 comes down. Good morning, Lucinda. Good morning, River. Glad you're both here. We're just going over 3 problems before we do the team quiz, but I'm glad you're here for the team quiz. All right, the next step here is going to be to add 1 to both sides so that we get our x term isolated by itself. Negative 7 plus 1 is negative 6. We divide by 6 because division is the inverse operation of multiplication, which we have right there, 6 times x. Dividing by 6, we have x is equal to negative 1. So that is the x value for our solution. No worries, Horner. River Horner. Sorry. All right, so here, now we need to solve for y. All right, so we're going to solve for y now, and we can plug in -1 for x into either one of our two equations. It doesn't matter which one. I usually try to show which one I'm going to use. I'm going to use this one right here. I'll bring it over. So I have y is equal to -4 times x, but x is -1, and then we have -7. -4 times -1 is +4, -7, y equals -3. So our solution to the system of equations is the point -1, -3, and we could check that by plugging in -1 and -3 into our two equations. If we plug -1 in here, this is -2. -2 minus 1 is -3, so that checks. I just did a quick little uh, check without writing anything down, just looked at it. So if we plugged in it was -1, -3. So if we plug in -1 here, this is going to be +4. So 4 minus 7 is -3, and that checks as well. And that will be the only coordinate point that works for both of them. Are there questions on this system of equations using substitution? The elimination method, no matter what method you use, as long as you use all allowable algebraic moves, you get the same answer. Great. Any other questions? All right. In the chat, what forms are these equations in? Give me the first form and the second form. If you only know one of them, give me the one. Yeah, the first one is slope-intercept form, which is y equals mx plus b. River, I'm glad you're back. And what's the second one? Anybody know? Uh, well, here is the y-intercept in the slope-intercept form, but I mean, what form is that equation in? It is called standard form. It's the standard form of a linear equation. Okay, so we have one equation in slope-intercept, one equation in standard. What method are you going to use to solve this system? Answer in the chat. Ten questions on the team test. Yeah, Mia, so you could make standard into slope-intercept form and then use substitution, but you can also just use substitution. So here's how you do that. Because this first equation is solved for y is by itself on one side of the equal sign, we can take what y equals and substitute it into y in the other equation. So just like last time, we use substitution. Hopefully you're going to get at least a half an hour, Thomas. So we have 3x minus 2 times the quantity, 2x minus 4, and then that's equal to 1. So notice here's y, and here it is substituted in. Questions on that substitution? Okay, so we're going to use distribution now. So we have 3x, negative 2 times positive 2x is negative 4x. Negative 2 times negative 4 is positive 8. And that equals 1. Next, I'm going to do 2 steps. I'm going to combine these two terms, and I'm going to subtract 8 at the same time, okay? And it's okay if you do that. You get negative 1x. When you combine these two, you get negative 1x. This makes a 0, so negative 1x is equal to negative 7. Any questions on that 2-in-1 step? If you don't like doing that, don't do it. Just do 2 steps. All right, now we need to, because we're multiplying negative 1 times x, we need to divide by negative 1, and we get x is equal to 7. Now that we've solved for x, we need to solve for y. I like this equation because it is already solved for y. So it should be easier to figure out what y has to equal. Y is equal to 2 times x is 7, minus 4. Whoops. Keep the colors there constant. 2 times 7 is 14, minus 4. 14 minus 4 is 10. So our solution is the point 7, 10. And if we plug 7, 10 into our two equations, put 7 in for x, this is 14. 2 times 7 is 14. Minus 4 is 10. So that's true. Great. If we put 7 in for x and 10 in for y, 3 times 7 is 21. Minus 2 times 10, that's 20, equals 1. 21 minus 1 is 1, equals 1, and that checks too. Questions? Uh-oh. Okay, so did you use the same process, Jojo, or a different process? Did I write too small, Jojo? Oh, okay. Does anyone else, is there a certain part that someone would like me to focus on and talk about? Good, Mia. I'm glad you understand so far. That's good news. Jojo, do you want me to wait a minute here, or how are you feeling? Well, I'll tell you what, Jojo. Let's pause here and take a 1-minute move break. In the chat, what form are both of these equations in? In the chat. Yeah, standard form. Awesome. They are both in standard form. And when we have two equations in standard form, we use what method? Elimination, that's right. Hey, Amelia, good morning. I'm glad you're here. Yeah, we use the elimination method. Excellent, excellent. Amelia, we're getting ready for a team quiz, and we are on the last problem, where this is the third of 3 practice problems. So, we cannot add these 2 equations and eliminate a variable. We can't subtract the second equation from the first equation and eliminate a variable. So that means we have to do some multiplication. Now, what multiplication can we do? Can anyone let me know first equation, second equation, and what the multiplication would be? The top equation multiplied by 2 or -2. Exactly. If we multiply this whole equation by 2, then we get a -4x. And then we can use subtraction. If we multiply by -2, then we get a +4x, and we can use addition. And that is the easiest way to do it. That said, sometimes we have to multiply both equations by something. And I can do that right now to demonstrate that process if you'd like me to. It can work on this one just as easily as it works on other ones. Do you want me to do that to show that process? How to pick a number? Okay, all right. So here's what I do. For this equation, first I decide which variable do I want to eliminate. I can eliminate the x or I can eliminate the y. It doesn't matter. I just have to decide one. I'm going to pick the y variables. So for this equation, I look at the coefficient of the y. Coefficient is the number in front of the y variable. And I say, all right, if I take this equation and I multiply it by 4, I will get 32x, because 8x times 4 is 32x. -2y times 4 is -8y, equals -8 times 4 is -32. Now I say, well, what do I multiply the other equation by? Well, I look at the coefficient of the y in the other equation, and it's a -2. Now, I want to add my 2 equations. If I multiply this whole equation by 2, 2 times -4 is -8y there. 2 times -4y is -8y. And notice that I won't be able to add them. So instead, I multiply by -2. Whoops, let me be consistent in how I'm doing this. I'm multiplying by -2. Okay, so now I have 5x times -2 is -10x. -4y times -2 is +8y. And check that out. A negative and a positive. I'm going to be able to add those together. Equals 17 times -2 is -34. Now I can take those 2 equations and add them together. 32x plus a -10x is going to be 22x. -8y plus a +8y is 0y, but I don't need to write in 0y. Equals, I got to keep those equal signs in alignment. Negative 32 plus negative 34 is negative 66. Now I can divide by 22 to isolate my x, and I get x is equal to negative 3. Questions on any of that? Does that help you understand how to choose what to multiply each equation by, I hope? Good. Naomi likes it. Anyone else? Anyone like, oh, yeah, now I see. I just choose the coefficient that I'm going to get rid of. I'm going to get rid of y. And then I look at the other equation, and I multiply this equation either by positive or negative that thing, and I get the result. I look at the coefficient of the other equation, and I multiply this whole equation by that thing, and now I can either add or subtract. All right. Now we need to choose one of our equations and solve for y. It doesn't matter which one. I'm going to use the orange one here. So I have, and I use the original equation, not the transformed equation. Okay, so I have 5 times x, well, x we just found for our solution is negative 3, minus 4y is equal to 17. 5 times negative 3 is negative 15, minus 4y is equal to 17. To get the y term by itself, we add 15 to both sides. That makes a 0 right here, which is what we wanted. So we have negative 4y is equal to, well, 17 plus 15 is 32. Now, to isolate our y, we divide by negative 4 because it was being multiplied by negative 4. And the result is y is equal to negative 8. So our solution to this system of equations is the point negative 3, negative 8, and that is the only point that will make those two equations true at the same time. Are there any questions? Okay.